Hey, this video is brought to you in part by my store over at Amazon.com. Yes, go to AirborneSurfer.com/Amazon. Take you right there. You can see all the groovy stuff that I work with and review and play with and the books I'm reading and all that fun stuff. Go over there, check it out. You'll find something that interests you. I almost guarantee it. Greetings, programs. Atari here, you there, and I've had this idea ever since I finished putting together the Arduino For Kooks video series. You can watch that playlist up here in the corner. It's a series of videos walking through various projects on the Arduino, basic level stuff, to get the viewer familiarized with the platform. And I wanted to be able to celebrate not only my having completed building that series, but also anybody that actually goes through the series and learns something and learns a new skill from it. So that brought me back to the idea of like merit badges, you know, where if you were in a scout program and you passed some test or whatever, and you would get like a little patch that, you know, showed that you were adept in first aid or wilderness survival or something like that. And so I wanted to build like Hacker Scout merit badges, starting with this Arduino For Kooks merit badge. And so I started thinking, why not have, in addition to that, having a tangible three-dimensional tile, if you will, a merit tile that I could put up on the wall and show off these various achievements. And that's what we're going to do in this video. We're going to design and print out a merit tile for this Arduino achievement, finish it up, and get it up on the wall. By the way, if you enjoy making things with Raspberry Pis and Arduinos and 3D printers and all that goofy stuff, go ahead and click the subscribe button. Don't forget to hit the bell notification icon, blah, 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 blah. But for now, tally-ho! So here is the Arduino's open source community logo. This is a logo that they have created that is fair to use in most circumstances. They have some limitations, like it can't be a commercial product, you can't put it on a board, things like that. I like the way it's put together. It's the Infinity Arduino logo kind of thing, but it's been broken out into different colors. So what I'm thinking of doing is actually printing each of those pieces that are different colors at different heights and then painting them with the corresponding colors. So in order to do that, what I need to do is I need to break these things out into their individual colors. Okay, here we are in Photoshop, and what I've done, you'll see it's all in black right now. What I've done is I've taken each of the colors, pulled them into a separate layer. So as you see, they're all in separate layers, and then converted each of those colors into a solid black. And you'll see why I've done that in just a moment. So now that I've converted this logo into different layers of each color, the next thing I'm going to do is save each layer separately as a PNG file with no compression and no interlacing. So now that we've taken each of those layers and saved them as their own file, as their own PNG file, I want to take those PNG files and convert them into an SVG, which is a scalable vector graphic. I could do that in Illustrator, but I think it's a little bit quicker to use an online converter. Just, it's quicker, easier, whatever. Convertio.co will do this very quickly. So all I have to do is upload each of the PNG files, make sure that they're all marked for SVG output, and then convert. Once they're converted, it'll take just a few seconds, you can download each of them in turn. And now we have 4 SVG files, each one containing the vector information for one layer or one color of the logo. Now I'm going to fire up Fusion 360 to do our 3D modeling. So here's where the SVG conversion comes in. What we can do in Autodesk is insert an SVG file. Line it up to the x-axis. I guess it's lined up on the, whatever, it's flat. This is the Z-plane. It's on the Z-plane. There we go. We're going to select our first layer. Now, it's a little big. Doesn't really fit on our grid, so we're going to scale it down halfway. That should be plenty big enough. Finish the sketch. See, there we are. Now, don't move anything just yet. Select the whole deal, and we're going to extrude with press pull. And let's go ahead and extrude that. let's see, there's 4 layers. We'll do them at 5mm increments. So let's do the first layer at 20 mils. Let's insert the next layer, line it up on the Z-plane. We're going to extrude those 15 mils. But it defaults to cut, so we're going to have to change that to new body. Okay, there we go. Now you see, starting to come together. Like, it looks like just a flat surface from the top, but as you kind of look at it from the side, it's got an interesting geometry to it. It's very important you don't actually move the model yet, because if you move it, it may not line up right. Okay, so there you go. There is the logo. Next thing we've got to do is we need to make a tile for it to sit on. I'm going to make a little hexagonal tile because I like regular hexagons because they go together as tiles really nicely. I'm thinking maybe 100 mils would be a good size. Not too big, not too small, just kind of somewhere in the middle. 100 mils, and then maybe like a 10 mil border kind of around it, so like you've got like an outside edge and then it's sunk down just a little bit. So I'm going to create a sketch, line it up on that plane, and going to set a circumscribed polygon. Place the center on the origin and take it out to 50 mils. So now it is, we finish that sketch, we can inspect, we can measure and say this to this is 100 mils. So that's the right size. Okay, good. Now we do this and we're going to make it 10 mils tall. Okay, now got our little tile essentially. We're going to do another sketch. We're going to do another circumscribed polygon, circumscribed hexagon. So center and take it out to 40. Here's the sketch. There we go. And that, take that, and we're going to take it down 5 mils. So we have a nice little 5mm recess. There we go. Now there's our little tile. So here we are. So we've got this. I need to, because this is like still really big. And that's 10, 20, 30, 40, 50. It needs to be less than 90. So I need to scale this whole thing. We're going to scale it. How big is it? That's 50, 100, 150, 200. We'll do it 25% to start. Let's see where it goes. 0.25. Move that whole assembly. So we're just over 100 wide, so I need to take it down a little bit more. Scale factor, I'm going to take it down to 0.1. Quite. Yeah, that'll do it perfectly. Okay, so I've thought about it a little bit more, and I think that because I want to paint these particular pieces, I'm going to print them all out separately, then paint them, glue them all together when they're done. So I have broken this down into its constituent components. We have the dark teals, the oranges, the gold, and the lighter teals. So each of those are going to be their own print, and then we'll combine them when they're finished. So what I'll do then, let's hide them all. Okay, so that's just the dark teals. Okay, so the last thing I have to do to put it all together is I had to create this little plate. It's 0.06 millimeters tall, and it's just going to be a base plate for each of the sections. Now that I've got that, I can export that. That's a dark teal. And then we do the same with the other colors. Groovy. Now I've got to throw this into Cura. Okay, so I got them all imported into Cura, ready to go. Let's slice it, push it over to Octoprint, and we'll get this thing started. Okay, so here it is. This is the final product. This is my hand-built Arduino Community Merit tile. Printed it out there on my multi-comp printer. And I like it. It's kind of nice. It is all hand-built. It is all hand-painted. It does have its little imperfections, but I kind of like that aesthetic, and it has its own character. It has its own marks and blemishes, and that is quite okay. I like to celebrate that. It has its own unique little history, and there it is in all of its glory. One of a kind, but if you want to make your own, I will leave the STL files down in the show notes on AirborneSurfer.com. Click the link in the doobly-doo. Print one out, build it, show me what you got, show me over here on the social media. Here is a video that YouTube thinks you will probably enjoy, and the show notes are going to be somewhere right around here. My name is Atari, and until next time, remember, it's okay. It's just a prototype. Tally ho, y'all.